In the previous chapter, we graphed quadratic functions, and we found that there were a variety of ways that a quadratic function could be written for us. One of them was vertex form. So if a function was written in y equals x minus h squared plus k format, then we could identify what the vertex was by just choosing out those numbers. The opposite of the positive negative sign of the h would be the x-coordinate, whatever number k was would be the y-coordinate of the vertex, and then we could just use our regular numerical pattern of moving to the left and right 1, up 1, left and right 2, up 4 to sketch the graph. So as long as we knew what the vertex was, it would be pretty easy for us to sketch the graph. If the equation is given to us in another format, we can graph it, but it's just not as simple. And a lot of times the only thing that we're interested in is the vertex. So if we had a way of rewriting the equation like what we see here in standard form, in vertex form, then we could get that vertex without really having to do anything else. And so that's what we're going to embark on. And we can do it by completing the square. But we're going to do all of our work just on one side of the problem. Because we've got this f of x or g of x on the other side, when we go to complete the square, we're not going to add something to both sides. We're instead going to add and subtract the same number to the same side. And we'll see what that looks like in just a moment. So starting with this one here, I'm going to go ahead and write it as f of x equals x squared plus 6x. And then just like I would under normal circumstances, I'm going to leave a little bit of a gap. But this time I'm not going to move this 3 to the other side. I'm just going to kind of move it a little bit farther over here to the right. So now I have to come up with what's going to complete the square for me. So I look at the number in front of the x, that's 6. I divide it by 2, and I then square it. So 6 divided by 2 is 3 squared. 3 squared is 9. So I'm going to add 9 right here. Now again, normally we would just add 9 to the other side, but I don't really have another side to work with here. So instead, I'm going to balance this out by subtracting 9 from this same side of the equation. So by adding and subtracting the same number, I haven't changed the equation at all, I've just changed how it looks. And so now what we're going to do is we're going to, so I still got my f of x over here, I'm just going to factor this part over here. I'm basically going to treat these as two separate parts of the same problem. On the one hand, I'm going to factor what I see here, so I'm going to break it into a couple sets of parentheses, which of course is going to be the same set of parentheses twice. It's going to be x, and then half of the b value before I square it. So half of 6 is 3, so I've got x plus 3 squared. And then I'm just going to clean up what I have over here. So 3 minus 9 is going to give me negative 6. And now we've got it. If you look over here, we can see that our equation is now in this vertex form. And so I can pick out what the coordinates of the vertex are. Once I've rewritten it this way, I know that it's going to be negative 3, because it's the opposite of the positive negative sign of the number inside the parentheses with the x, is our x-coordinate, and then negative 6, whatever number I see on the outside, is going to be my y-coordinate. So this is a way that we can use completing the square to help us rewrite a quadratic function in vertex form if it was given to us in standard form. So for the second one, we have a little bit of an added difficulty because we have that negative in front there. And again, normally we would just divide by negative 1 everywhere, but I can't do that in this case because everything I do has to happen on just one side of the equation. So we're going to have to work around that a little bit, but we'll see how that works. So I've got g of x equals, I'm going to start off and I'm going to separate the x's from the non-x piece. I'm going to put that over here just off to the side. Now before I can complete the square, what I'm going to have to do is I'm going to have to undistribute a negative 1 from both pieces here. Because again, I can't complete the square as long as there's something other than just 1 in front of the x squared. So I'm going to factor out a negative 1. And so when I take that out, the x squared becomes positive, and then the 8x is going to become negative. And of course, I still have my minus 10 hanging out over there. It's all on the same side. I've just written it a little bit separately. So now I'm ready to complete the square. So I take half of this number here, so that's going to be negative 8 divided by 2, and then I've got a square. So negative 8 divided by 2 is going to give me negative 4 that's going to be squared, so then that means I need 16. So I'm going to add 16 inside the parentheses here. But this is where things get a little bit tricky, is I didn't really add a 16 to this right-hand side of the problem, because this 16 is being multiplied by this negative 1. So that means I didn't add 16, I actually subtracted 16. I added a negative 16. So that means I'm going to have to introduce the opposite. So if I really added negative 16, then that means I need to add a positive 16 to balance things out. I know that's confusing, but whatever is inside the parentheses being added here is also being multiplied by that negative 1 that's out front. So we really introduced a negative 16, so I had to add 16 to keep things balanced. Those have to cancel each other out. But once we're here, we've got g of x equals, so I'm still going to have this negative 1 out front, and then I'm ready to factor this set of parentheses here. So I've got x, I know it's going to be squared, and then this number here is always half of the b value, so it's going to be minus 4. And then over here, I'm going to gather up the negative 10 and the 16 to make plus 6. So this negative 1 just means that my parabola is going to be opening upside down, but that doesn't affect the location of the vertex. My vertex on this one is going to be, again, opposite of the positive and negative sign that we see there. So it's going to be positive 4 and then positive 6.